So for the third strategy, we went with a low robot that would go under the trench to have faster cycle times, and you can utilize that safe zone of the trench to have a less defense. We also went with the two-wheel shooter because it will be more accurate. It'll cause less. With the one-wheel shooter, it'll cause more friction and spin and
have more tangential velocity.
Yeah.
Spin isn't necessarily a bad thing.
They will actually like help detract other like air resistance and all that.
Yeah, spin will cause a straighter, more
But
consistent shot.
it won't like having it with one wheel. It would cause spin, but it'll slow down the ball. Like it'll slow it.
You won't create enough
Enough.
power to give it enough.
I don't know if you can say that.
It might cause more spin.
You get more power.
I mean,
from
these
the-
are really
From
powerful
the videos
motors.
that I've seen, the one-wheel shooter has less accuracy than the two-wheel shooter because it causes different amount of other
Speed
forces.
variation.
Yes.
I know I've seen like a Robonauts video where they had a one-wheel shooter, and I think they're one world. So
But
we could
it wasn't the squishy balls. I mean,
yeah, they were.
Also, we wanted to utilize the no problem wheel for the color sensor on the control panel. This is.
Oh yeah.
So it'll be a motor that comes out and it turns the wheel, and you would have the color sensor on the bottom since it has a plexi. So that way, if you have the color sensor on the bottom, the color sensor won't be affected by the light since it'll be covered by the wheel itself. There's also color on the bottom of the wheel, by the way. We also utilized a front shooter with a front intake. That way, you drive up to the balls forward, and then when you go up, you're already ready to shoot, and you don't have to turn around, or you have to drive backwards when intaking balls. We also wanted to do a narrow configuration. That way, it's easier to go through the trench. It'll be a full perimeter, covered on all sides. We won't have a pass through. That way, it'll be more robust against defense. We wanted to do a linear intake, where like 148 last year, their intake came out with pneumatics. It'll go out. We wouldn't have a roller. We would have mechanism wheels and some compliant wheels, but it'll go out and then it'll go in whenever we're ready. Whenever we go to the other side to play, when they're playing defense, because we want to be able to have all the pieces inside our frame perimeter to prevent breaking parts when they're playing defense against us. We also we got our best auto and our low auto with 3 cells, and going into the 3 inner shots, that would be 18 points plus moving out of the line. That would be 5 points. That'll be a total of 23 points for our best. Our not best would be 17 points, which is also still pretty good because we were shooting up. And the way we would maximize getting the 23 points on the inner is by before, when we calibrate at the beginning of the competition, we have an adjustable 2-wheel shooter where it's a manual adjustment. So once you test it, you have a manual. You can set it down with like a wrench. That way it won't move, and you can guarantee that at that line in the center of the field, you'll always get the inner. And then if the linear intake is not able to reach as far low, you can always move it down to have it go in and out lower. Also have a picture of the intake. This is 148, but in the Robonauts scheme, just because there's more contrast between the parts. This has a piston, it goes out on a linear system, and it has the intake. 148 would go out, and then we want to make sure that we don't have a pass-through, because it'll allow us to go a touch and own it. So once you touch the ball, it'll be yours, because with that intake mechanism, it'll always, once you have it, it'll go inside. We also have the possibility of driving up to, when we extend our intake, we also have the possibility of just extending it, and then we're right up on the alliance, on the loading station, and the balls will just fall on top instead of having to fall down and then intake it ourselves. So that's another possibility.
Like, if this is our intake, it comes out. But how are we gonna index it though? Because we're gonna have balls like
We have
all across.
Magnum wheels, 2 Magnum wheels, and 2 Magnum wheels, and 2 compliant wheels. So the balls will index in and it'll go into one single area.
Okay. And
We,
Wait,
but how are they gonna index like that over a bumper?
Alright, okay, so
Because then when you
I
have
can try.
second row, yes. Okay.
So this is the robot. It's full perimeter. Then you would have a bumper. You would cut a slot on the bumper. That way, when the intake comes out, you have Magnum wheel here, 2 compliant wheels, Magnum. So once the ball goes in, it'll go in here, it'll roll this way, and then the compliant wheels will push it up through between the bumper. That way, it'll always be through this gap, and it won't want to move around on the bumper. And it allows it to be, instead of the ball going up around the bumper, it just goes straight through.
Yes.
That is one thing about this system. The other thing is with a short robot of around 2 feet from the ground, we would have the shooter on this point. So we intake balls over here, and then we shoot them. Oh no! Oh no! It is
Why
that
is
way.
it in the corner?
That way, if they're playing defense against us, we just shoot over them.
It's in the.
It's on the back. This is the front.
Oh, but I was.
We're
Why
shooting
isn't it
this way.
centered?
The shooter.
Yeah. Like,
Why isn't it here?
No, why isn't it here?
The shooter.
Yeah, it's not.
This is
That's supposed to be like the plane.
This is a bumper.
Oh, I'm dumb. I thought that was top view. I was like, what's going on?
So we intake in the balls, and then we would have a mechanism. We haven't decided on if it's gonna be straight and then up, or if it's gonna go around. But it'll be on the back area.
And 4-wheel drive.
It'll be 3 wheels.
8-wheel drive.
The belt.
Six-wheel drive.
No, 8-wheel.
Oh, 8-wheel. Oh yeah, the 8-wheel.
We should go with 8-wheel.
What do you mean?
8-wheel drive.
Four
more,
wheels on
more,
one side.
yeah, more stability.
That's another thing.
There would be more friction against defense.
When going over the 1-inch
turning-
rendezvous point,
I mean, this is like
You shake a lot.
It's like robustness versus agility.
yeah.
Well,
Either way, this is like a design problem. This isn't a strategy problem.
Since we would have a limelight, we don't have a turret. We want to be able that we can move down. So with the Anymark drivetrain, we have an 1/8-inch drop down, so it's very easy to turn. So with the limelight, you just exactly align. Another thing, we would be climbing with a mechanism that would
But where are we shooting? Like, what's the goal?
to shoot the high goal.
So like, we're trying to shoot the high goal. Well, here I just want to point out one thing. Like, my strategy from before is allowed. Whoever said you weren't allowed to like drop them off, you are allowed to do that.
No, yeah, it is.
That so you are allowed to do.
You're just not. You're not allowed to cross.
You're not allowed to like shoot the balls out of the field. Is what the rule
You're not allowed
is.
to shoot them cross. though.
Yeah, but basically we wouldn't be shooting them. We would be rolling them to the.
Okay, you can explain the other strategy.
They-
When I'm,
Well, I'm just saying like I thought we were gonna start like because you've been up here for a while. I thought like,
Well,
you
it's
start-
like-
You'd wanna
like you
share.
just started going into robot design and I
no,
was
this
like,
is like our strategy.
Oh, that's the extra design, like the other ones don't count.
No, like this is strategy we discussed. I'm not going into.
this is like the bumper design.
I have a mechanism, like I have an idea of a mechanism to climb, but we haven't discussed it. But we did have a discussion on, we would be able to pick up other robots. So the way we would do that is we would get other teams that have an Anymark drivetrain. We would put a bar. So this is the front view. This is their bumper. We would put a bar on their drivetrain. That way, whenever they go inside the area, the rendezvous zone, they could drive next to us. Our robot would be here. We have a mechanism that would go down, and it would hook onto the bar that we cheesecaked into the robot.
Oh, I like this method, the cheesecake method.
How does it work?
It's a cheesecake mechanism that we put onto other people's robot. It's a bar here, and then we have a mechanism that goes down, pivots down with a piston, and it would hook onto the bar that we put on, and then this is bumper support.
Yeah.
So then we would be able to lift them.
Yeah.
So
Hey,
we
do we have
would
to get re-inspected?
we would
they would have
Yes,
to
they
be.
would have.
So we would put that bar onto another team.
Do other
Like,
anti-mark drivetrains
Yeah.
with some
only
screws.
And we'll
Anti-mark
and we'll
drivetrain.
make sure that our mechanism can grab that like 100% of
It
the
is-
time.
it's actually
that's
pretty-
better than us trying to grab onto some piece that we find randomly.
That's true.
It's actually a pretty safe bet because many teams that like don't have like a really high like
Yeah.
one are going to use the anti-mark mechanism, the
That-
anti-mark system.
Drivetrain,
Yeah.
The good thing
Especially,
about that
like,
idea,
especially like
Alliance.
Pasadena, there's gonna be a lot of them there.
Yeah.
the good thing about that idea is that when we go to Del Rio, there most likely will be
Will
a lot of
be
robots
those,
with that.
Yeah. So
So it will be worth the reinspection.
So we would, I think we could get all of this done, like in 7 weeks. I feel like the hardest thing is climbing, but I feel like we could figure it out. Like there's teams that have about the same resources as us